Hi, my name is dr. Ahmath. Welcome to the course of Probability and Statistics. From this lecture, we're going to start talking about the probability, and especially in this lecture, we're going to define what is the probability from the mathematics perspective. So you have probably heard about this word probability, right? So you have heard about this kind of statements that if it is cloudy today, most probably it's going to rain. Or your chances to get a tail when you toss a coin is 50 by 50. And what does it mean, actually, this probability? And what does it mean when we say that your chances is 50 by 50? So probability that some event is going to happen is basically how likely this event is going to happen. And we are usually going to estimate this likelihood of happening some event using the percentages, like from 0% to 100%. So when we say that, hey, probability that it's going to rain today is 80%, it means that, yeah, most probably it's going to rain. And when we say that, hey, probability that your professor is going to record your next lecture on time is 20%, it means that most likely it's not going to happen. From the mathematics perspective, we are going to denote the probability using the numbers between 0 and 1. For example, when we say that your chances to get a tails when you toss a coin is 50%, so from this sign, from the mathematics, it is going to be denoted as 0.5, like just a number between 0 and 1. So in overall this course, we are going to mix these two concepts, like the percentages and the numbers between 0 and 1. So be ready to understand that they mean actually the same thing. So probability that some event happens is 100%. It means that probability that this event is equal to the 1, and so on. So before we, I just like to give you a small examples to try to catch the idea of the probability from the mathematics perspective. So let's say I've got a box with a couple of balls, with 3 balls actually. 3 yellow balls. I've got 1, 2, and 3 yellow balls. So if I say, hey, just choose one of the balls, and what's the probability that it's going to be yellow? Probability of choosing a yellow ball from this box is going to be actually 100%, right? So you are going to choose a yellow one for sure. It's going to be 100%, or we usually denoted this as simply 1. So now let's say I've got another box with not only was the yellow balls. For example, I've got 3 yellow balls and 1 pink. So now if I say, hey, if you choose one of the balls randomly, what's kind of probability of choosing a yellow one? So I would, yeah, so and I need to estimate this mathematically. So, and one of the ideas of estimating this probability mathematically would be to just connect this with the proportions of the items inside this box, basically. So if there are 70%, so if the 75% of the balls inside this box are yellows, then probability of choosing a yellow should be also 75%. So it's going to be 0.75. So if only 25% of the balls inside the box are pink, then probability of choosing a pink one should be also 25%, where, as we said before, we are going to denote this as the numbers between 0 and 1. So this is the simple idea of probabilities. Basically, what we are going to do is we are going to just collect all possible outcomes of the events, right? So in this case, if you choose one of the balls, you are going to have one of these events are going to happen. Then we are going to find out the proportions, and those proportions are actually going to mean probability. So from the mathematics perspective. So later on, we are going to try to understand why this probability actually doesn't work. And in a short time, for example, if you do this experiment a couple of times, why it doesn't always work? And we will try to go deeper and deeper into the meaning of the probability and its applications. But at this time, we are just defining the probability from the mathematics, right? And we are going to just connect this with the proportions, with the proportion of the items, or with the proportion of the event inside this big space. So yeah, and talking about this like a big space is slightly inconvenient for me. So let's define the notation for the simple cases. Like, so if you have some experiments, so experiment, which is going to give you a random output, or any output, is going to be called as a probability experiment. And this might be anything. For example, just tossing a coin, or choosing a ball from the box, or like your professor is coming to the lecture. So many things. It's going to be experiment. And all possible outcomes of your experiment is going to be called as a sample space. So the sample space is the set of, actually, it's the set of all outputs of your experiment. For example, if you have another box with 3 yellow balls, with 1 pink ball, and 2 white balls, then the sample space is going to be a set, which is going to contain all possible outputs. So you choose one of the balls, and what kind of output you can have? You can have yellow 1, or yellow 2, or yellow 3, right? You can have pink 1, you can have white 1, white 2, right? So the set of all outputs from your experiment, which are coming from your experiment, is going to be called as a sample space. And we are going to denote this using a capital omega letter. So this is the capital omega letter. So now what I would like to do is I would like to define the events. Again, the events are going to be sets. So for example, if I want to evaluate the probability of choosing a white ball, I'm going to make a set. So what kind of outputs is going to be my set? So white balls, it's going to be white 1 and white 2. These 2 balls are white, so that is why they are going to fulfill my set, right? So now, if I would like to calculate probability of choosing a white ball, what I have to do is I need to basically find the proportion of the set W, inside the sample space omega, right? So one of the ways of finding the proportions would be to just count the number of the items inside the event and just count the number of the items inside the sample space. So how many items we have here in the W? So we have only 2 items here inside the W, and how many items we have here inside the omega? So 6 items, right? So it's going to be 2 over 6. So this is going to be the probability of choosing the white ball, and we have just connected this with basically the proportions, basically the sizes of the events divided to the size of the sample space. So and so in our next lectures, we're going to try to make this concept a little bit more difficult, to see the more difficult sets.